All right, guys. Video number 2, simplify expressions. So a rational expression is in simplest form when the numerator and denominator have no common factors except one. To simplify a rational expression, divide out any common factors of the numerator and denominator. So before, when we did monomials, if you had a common factor of, say, a, like that, you could cancel out the a's and you'd have b over c. Now with rational expressions, if you have a polynomial in the numerator and denominator, factor it if you can. So the GCF in the numerator is 3 and denominator is 4. So if you factor those out, you can see the common factor of x minus 3 to the numerator and denominator, and those cancel out, leaving just 3/4. So which expression is equivalent to negative 3x squared times 4x to the 5th divided by 9x to the 6th? Well, first thing you got to do in this situation is the expression represents the product of two monomials and the division of that product by another monomial. And then we can factor the numerator and denominator using their GCF. And you can get a 3x to the 6th out of the numerator and denominator. Those cross cancel and you get negative 4x over 3, which you could rewrite as negative 4/3 x, which is choice D. Another way to do this is to first multiply out the numerator. So you could get negative 12x to the 7th over 9x to the 6th. And then you could see that the 12 and the 9 both have a factor of 3. And the x to the 7th and x to the 6th have a common factor of x to the 6th. The denominator, all that would be left is a 3, and the numerator would have a negative 4x left over. Then you'd cross cancel, or you cancel out the 3x to the 6's. Okay? Cool. All right, here's one for you to try. Which expression is equivalent to 16c to the 4th b to the, or 16c squared b to the 4th over 8c cubed b? Go ahead and pause the video. All right, we're back. So the numerator and denominator both have a factor of 8. They both have a c squared, and they both have a b. The denominator, after you factor out the GCF of 8c squared b, would have just a c left over. And the numerator would have a 2b cubed. So these cancel out. And you'd have 2b cubed over c. So the correct choice is F for that one. Okay. Sound pretty good? All right. So you can use the same procedure to simplify a rational expression in which the numerator and denominator are polynomials. So let's simplify 2r plus 18 over r squared plus 8r minus 9 and state the excluded values of r. So first thing you want to do is factor the numerator and denominator. The numerator you can factor out a 2, and the denominator you can factor into two binomials. Note that negative 9, two numbers that multiply to negative 9 and add to a positive 8 are positive 9 and negative 1. So that's how we factor. Now, once you have the factored form, you can list the excluded values by seeing what numbers make the denominator 0. Now, we already factored the denominator, so you get r equals negative 9 and r equals 1. Those are the excluded values. So r can't be negative 9 or positive 1. Then you can go back and see that you have a common factor of r plus 9 to the numerator and denominator. Cancel those out, and you have 2 over r minus 1. Okay? Now, here's the thing. You state the excluded values before you cancel out the common factors. Okay? Because if you just look at the final answer, it looks like just r equals 1 should be the excluded value. But remember, you're getting the excluded values of the original problem before you're simplifying it. Okay? So like what I like to do is factor it first, get my excluded values, list those, and then and then simplify it. Okay? Here's a couple for you to try. Go ahead and pause the video. Okay, we're back. The numerator is, for number 4a, is n plus 3. And the denominator would be n plus 7 times n plus 3. So the excluded values would be n is not equal to -7, and n is not equal to -3. Now you can cross-cancel the factor of n plus 3. The most common mistake I see is that students would put n plus 7 as my answer. But it's not. It's n plus 7 underneath a 1, because these technically cancel out to 1s, because n plus 3 divided by n plus 3 reduces to 1 over 1. So you still have the 1 as kind of like a placeholder for the numerator, because that n plus 7 is still in the denominator. It doesn't magically go up to the numerator. Okay? The next one, y squared plus 9y minus 10 over 2y plus 20. So you can factor out a 2 from the denominator and get y plus 10. And then the numerator, two factors of -10 that add to positive 9. So one has to be positive, one has to be negative. The larger has to be positive. And the factors would be y plus 10 and y minus 1. Okay. The excluded values are y equals -10, or not equal to -10. And then you can cross-cancel a factor of y plus 10. And you have y minus 1 over 2 is your fully simplified form. Okay? And notice that your final answer, you wouldn't get the value of -10 from it. That has to come from the factored form of the original problem. Okay? All right. When simplifying rational expressions, look for binomials that are opposites. For example, 5 minus x and x minus 5 are opposites because 5 minus x is equal to -1 times x minus 5. So, if you have binomials that are opposites, you can write the 1 as the -1 times the opposite of it. So, in this case, let's simplify 36 minus t squared divided by 5t minus 30 and state the excluded values of t. So I want to exclude the values for which the denominator is 0. So I set 5t minus 30 equal to 0. Add 30, divide by 5, and you get t equals 6. So t cannot be 6. Now, when I factor this, the numerator is a difference of squares. So it's going to be 6 minus t times 6 plus t. The denominator I can factor out of 5, so it's 5 times t minus 6. Notice that 6 minus t and t minus 6 are opposites. Okay? One is a positive 6 and a minus t. The other one's a positive t and a minus 6. So I can write the 1 as the 1 in the numerator as -1 times t minus 6. Another way to think about it is that if you truly have opposites like this, they will cancel to a -1. Okay, so just think about it. If I had -10 divided by its opposite, 10, that would be -1. If I had if I had 14 divided by -14, those reduce or simplify or divide to -1. Okay, so these opposites are going to cancel to -1. So you have a -1 there, and then you just have -6 plus t over 5. Okay. Right, here's a couple for you to try. Go ahead and pause the video. All right, we're back. 5a, factor out of 12, so you get x plus 3. And the denominator is going to be x minus 4 times x plus 3. Okay. The excluded values are x not equal to 4 and x not equal to -3. Okay. And then this one, the x plus 3's cross cancel, and you have 12 over x minus 4. And that's your final answer there with the excluded values. Okay, no opposites in that one, so we didn't have to cross cancel anything to a -1. 5b, you would have numbers that multiply to -35 and add to -2. So one has to be positive, one has to be negative. The larger has to be negative, so it'd be -7 and 5. The denominator, two numbers that multiply to 14, positive 14, but add to a negative. The only way that can happen is if both factors are negative. And so x minus 7, x minus 2. So the excluded values are x not equal to 7, x not equal to 2. can cross cancel out a factor of x minus 7, so you have x plus 5 over x minus 2. Okay. Now, what if I had 25 minus x squared over 8x minus 40? When you factor that, you'd have 5 minus x times 5 plus x all over 8 times x minus 5. Okay, the excluded value would be x equals 5, so x not equal to 5. And then notice that in this case, the 5 minus x and the x minus 5 are opposites, so those are going to cancel to a negative 1. So you'd have negative 1 times 5 plus x over 8. Another way you could have written that is just put negative in front of the fraction. Okay? All right. Recall that to find the zeros of a quadratic function, you need to find the values of x for which f of x equals zeros. Well, the zeros of a rational function are found the same way. So find the zeros of x squared minus 3x minus 18 over x minus 3. So you have the original function, and we set it equal to 0. Now think about this. To get a fraction to be equal to 0, you have to have the numerator equal to 0. So that's where we're going to go. But first, here's the thing. To do these types of problems with rational expressions, when you're trying to find the zeros, okay, you have to factor it first and cancel out common factors. Or, excuse me, you have to find the excluded values first, okay? Because it might turn out that a number makes the numerator 0, but it also makes the denominator 0. And that would be an excluded value, even though it makes the numerator 0. If the denominator is 0, you can't divide by 0, even if you have 0 in the numerator. So you have to figure out the excluded values first. Okay, so let's divide out the common factors here. And then you would have x plus 6 equal to 0. So when x is negative 6, the numerator becomes 0. So f of x equals 0. Therefore, the 0 of the function is negative 6. Okay, here's a couple for you to try. Go ahead and pause the video. Okay, we're back. So 6a, the numerator factors into x plus 5 times x minus 3 all over x plus 1. So the excluded value would be x cannot be negative 1. But the zeros are when x plus 5 equals 0. So you would have x equals negative 5. And x minus 3 equals 0. So that'd be x equals 3. Okay? So basically, the excluded values are what make the denominator 0. The zeros of the function are what make the numerator 0 after you cancel out any common factors. Now, like in this case, we didn't have any common factors to cancel out, and that might happen. That happens a lot, and that's okay. They don't always cancel out. Okay, so excluded values are what make the denominator 0. The zeros of the function are what make the numerator 0 after you cancel out any common factors. Okay, so the numerator here would factor into x plus 4 times x plus 2, and the denominator would factor into x plus 2 times x minus 1. Okay, the excluded values are x not equal to negative 2 and x not equal to 1. You cancel out a common factor of x plus 2, so you have x plus 4 over x minus 1. And then the zeros are when x equals negative 4. Okay, because that's what makes the numerator 0. All right, so again, excluded values are what make the denominator 0. The zeros of the function are what make the numerator 0 after you cancel out any common factors. Okay? All right, guys, well, that's it for this section. Please continue on to your assignment and let me know if you have any questions. I'm here to help. Take care.